Hello, and welcome to Functions and Models. My name's Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. Modeling. Alright, to mathematically model a situation means to represent it in mathematical terms. The particular representation we used is called a mathematical model. Now, this whole idea of mathematical modeling is actually the best way of phrasing it, but old school, we're looking at word problems. We're taking a situation, we're looking at what's going on in real life, and we're throwing math at it to describe it. That's it. Important thing to keep in mind, though, is mathematical models do not always represent a situation perfectly or even completely. Sometimes it's only an approximate representation, sometimes it's only for certain years or under certain situations, or maybe we're only looking at certain aspects of the situation. So it's dependent on the situation that we're modeling. So don't think that a mathematical model is going to be all-encompassing. It very rarely is. So the types of models that we could see. An analytic model is obtained by analyzing the situation being modeled. Curve-fitting models are obtained by finding mathematical formulas that approximate the observed data. We use linear, quadratic, cubic, quartic, just polynomial regressions in general. Great classes on these you can find at your university. I know that UTEP and Doña Ana Community College / NMSU both have these classes. Continuous models are defined by functions whose domains are, let's throw a little r in there, whose domains are intervals of the real line. So that might be something if you're modeling height of students in a class. And heights, it's a natural continuous function. It's not like we jump from 5'7", now I'm 5'8", right? You have to hit 5 1/8, 5 1/4, 5 1/2. It's a continuous type of thing. Whereas discrete models have only set points as the domain. Discrete mathematics, great class to take if you're going to be going into more math. Hint, hint, engineering, science majors, math majors, obviously. Discrete models are used extensively in probability and statistics, so if your major includes taking a statistics class, you'll see more of the discrete models as well. Alright, let's look at some examples. The amount of free space left on your hard drive is 50 gigabytes, and it's decreasing by 5 gigabytes per month. Find a mathematical model for this situation. Alright, the first thing I do is I look at what's changing. Alright, it's decreasing by 5 gigabytes per month. This per month tells me that each month I'm losing gigabytes. Okay, I'm losing free space gigabytes. I know that 50 gigabytes is fixed. Alright, that's how much space I have on my hard drive as I'm starting the semester. So I'm going to let X be the number of months. That is what varies. That will be my variable. Then the free space as a function of the number of months into the semester is, I start with 50, decreasing, so I subtract, 5 gigabytes per month, so 5 times the number of months is how much I've used up in that amount of time. My function is f of x equals 50 minus 5x. You could use a couple of test values, what you know from real life, just thinking about it. Plug in the number of months here, see if it works out. If your pattern looks reasonable, you probably nailed it. Example 2. My square orchid garden is right off the side of the house, so that the house itself forms the northern boundary. So I don't have to do anything with that. The only thing super important, really, in this first sentence is the fact that I'm using a square orchid garden, so squares. And the house forms the northern boundary. The rest of it, blah, 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 blah. So, the fencing for the southern boundary costs $4 per foot, and the fencing for the east and west sides costs $2 per foot. I want to find the total cost function as a function of the length x of a side. Now, it's a square, so I know every side has length x. And I don't have to fence the top, the northern boundary. So let's start over here in the east. $2 per foot multiplied by x feet. It's going to cost 2x to fence the east side. The southern boundary costs $4 a foot, It's a square, so it's still x feet across. So it's 4 times x to fence the southern boundary, and again, 2 times x to fence the western boundary. So the cost function is east costs 2x, south costs 4x, the west costs 2x. X is the same number of feet on each side, so 2 plus 4 plus 2 will give me 8x. The cost function is 8x. Depending on how many feet on the side of my square, I know exactly how much money I'm going to need in order to fence it. Alright, in general, a cost function specifies the cost C as a function of the number of items x. Thus, C of x is the cost of x items and has the form cost is variable cost plus the fixed cost, where the variable cost is a function of x, so it changes with whatever our variable is, and the fixed cost is constant. Like, you have to pay this much to make this product no matter what. And then we add on the variable cost. It depends on how many you want to make now. So if we have a cost function of the form C of x equals mx plus b, we call this a linear cost function. The variable cost is the portion that includes the variable, so mx is the variable cost. Suppose you're old school and your band wants to burn some CDs. The variable cost, how much it costs based on how many CDs you want to burn. The fixed cost is B. Maybe you're paying recording studio time. It's going to cost you this much for your studio time and engineering, no matter how many CDs you choose to burn. The marginal cost is the cost for one more, that's M. So your variable cost is how much it's going to cost to burn each CD after you have the fixed cost of engineering and studio time. But the marginal cost M is, oh, I have it set up that I want to burn 90. What if I want to do one more? How much is that one more going to cost me? That's the marginal cost, the cost for one more. Similarly, the revenue resulting from one or more business transactions is the total payment received, sometimes called the gross proceeds. I'm going to call it revenue. If R of X is the revenue from selling X items at a price of M each, right? You go to the store, you find a perfect pair of jeans for 20 bucks. You know I'm not shopping a couple of places you people shop, I'm just saying. The revenue for the company when I go check out is 20 bucks multiplied by the number of pairs of pants I find. So that's revenue also. Let's go back to our band, burning CDs. They want to make some money, they're playing a show, they want to sell them. 10 bucks a CD, $10 multiplied by the number of CDs they sell is their revenue. You'll notice there is no fixed revenue. You are not guaranteed to sell a CD, because you know somebody was there and they recorded it and they're going to upload it and distribute your music for free, and you're still going to be popular worldwide. You're just not going to sell any CDs, and that's okay too. The selling price M can also be called the marginal revenue. All right, so the amount of money that the company or the band makes for selling one more, marginal. Let's put these two concepts together, the cost and the revenue, and we'll get the profit. The profit is the net proceeds, or what is left of the revenue when costs are subtracted. If the profit depends linearly on the number of items, the slope M is called the marginal profit. No surprise there whatsoever. Profit, revenue, and cost are related by the profit that you earn is the amount of money you get from selling your CDs at the show minus the cost it makes to make them, right? You have to pay your costs out of your revenues, and if you have money left over, fantastic, you've made a profit. And we'll use the formula P of X equals R of X minus C of X. Break even, the break even point's super important, right? I'm in this band, I want to get known, and I want to break even. I don't want to lose money making a bunch of CDs that nobody's going to buy. I also don't want to run out of CDs to sell. So when my profit is 0, it will be the break-even point, because I'm not making a profit, but I'm not losing money. So it's a nice little equilibrium that's going to come up here in a minute. If the profit is 0, notice the profit is the revenue minus cost. And if I add cost to both sides here, using this equation, add cost to both sides, cost equals revenue is also a break-even. So if you have a profit function, set profit equals 0 and solve, you'll have break-even. If you don't have a profit, but you do have cost and revenue, you can still find it without having to first form your profit. So revenue equal to cost or profit equal to 0 is break even. Every CD I sell after that, I'm making some money. So let's look at your college newspaper. Your college newspaper has fixed production costs of $70 per edition. All right, fixed. It doesn't matter how many papers they print. It's going to cost them $70 to make it every edition. Marginal distribution costs are 38 cents per copy. So now it varies, right? How many copies do we want to print? Well, that's the variable cost. The paper sells for, or your college newspaper makes a revenue of, 48 cents per copy. That's how much it costs to buy one more. There are 5 things we want to do here. We want to write down the associated cost function in dollars, the revenue function in dollars, and the profit function in dollars. And then we're going to use the profit function to find out how much money the college newspaper is making from various sales. And then we're going to find out how much they absolutely have to sell in order to break even. You don't want your college newspaper losing money, because that would probably result in a raise in tuition. Alright, so all of that, your college newspaper, blah, 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 that's encapsulated in the ellipses, ... The important part, fixed production costs of $70 per edition and marginal distribution costs of 38 cents per copy. Let's let X. It looks like there's a per edition. Now, am I talking about editions? Am I talking about copies? This is what varies, right? The fixed cost is $70. Fixed is not changing, so edition is not going to be our variable. But the number of copies of papers we're selling and producing, that's what changes. So let's let X be the number of copies of the paper that they print. The associated cost function in dollars is C of X equals 38 cents multiplied by the number of papers they print, plus the fixed amount of $70 every time they make a new edition. The paper sells for 48 cents per copy. So as the view of the college newspaper, our revenue is 48 cents, right? Make sure you use appropriate decimals, right? Because dollars is our unit here. So 48 cents multiplied by the number of papers they sell, that's the revenue they take in. Using our cost and revenue functions appropriately, we can write down the profit function in dollars. P of X is R of X minus C of X. R of X is 0.48X. Anytime I'm subtracting stuff, not the technical term, but that's what I use. Anytime I'm subtracting stuff, I always make sure I use parentheses so that this negative sign distributes. That's 0.48X minus 0.38X. That's a profit of 10 cents every time we sell a paper. However, this minus also goes to the 70. In order to make a profit, you have to overcome the $70 for printing the edition, and you're only making 10 cents on each copy, right? It costs them 38 cents to make. It's sell for 48 cents. They're making a profit of 10 cents. Check every once in a while the reasonableness of each of your steps. Does that seem reasonable for the situation? Well, yeah, it does. So let's move on. All right, so we have our profit function here from the last slide. And we want to know what profit or loss results from the sale of 100 copies of the paper, and what about 500? Well, 100 copies of the paper, remember X is the number of copies. So let's put 100 in for X. 0.10 times 100 minus 70, we'll do our multiplication first. 10 cents, 100 copies, that's going to make $10. But we still have that $70 we have to overcome. 10 minus 70 is minus 60. If your profit is negative, that's a loss. 100 copies of the paper will give a loss of $60. Similarly, if I want to know about selling 500 copies, P of 500 is 10 cents multiplied by the 500 copies, minus the $70 we have to put out just to make the addition. 10 cents of 500 times is $50. 50 minus 70 is a negative 20. So 500 copies of the paper will give a loss of $20. So I notice I don't say 500 copies will give a loss of negative 20. The negative is the word loss. So double negatives, you have to watch that and how you state things. How many copies should be sold in order to break even? P of X, we know our profit function, that's 10 cents X minus 70. So I want you to hit pause, give it a minute, try it. Math is not a spectator sport. My students can be so sick of hearing that from me. But you have to do it to learn it. So hit pause. When I come back, we'll talk about it. Alright, so did you actually hit pause? Just curious. Solve it. P of x equals 0. So what I did is I wrote down the P of x, the point 10x minus 70, and I set it equal to 0. In order to solve this, I'm going to add 70 to both sides of the equation. When I add 70 to the left, I'm left with 10 cents x, equal sign, on the right-hand side, 70. To get x by itself, I'm going to divide both sides by 10 cents. I'll be left with an x on the left, and 70 divided by 10 cents. How many dimes do you need to make $70? 700. So if x equals 700 copies, that means the college newspaper needs to sell exactly 700 copies of the newspaper in order to have a break even. Any amount of papers over 700, now the newspaper's making a profit. The Metropolitan Company sells its latest product at a unit price of $5. Variable costs are estimated to be 30% of the total revenue, while fixed costs amount to $7,000 per month. How many units should the company sell per month in order to break even? As you're reading through a word problem, it's easy to kind of get overwhelmed. So when I read it through the first time, I try not to focus on the details. I just kind of read it through. What's the situation? What's going on? Okay, it sells, so I'm going to have some revenue. Here's some costs. Oh, it's kind of like what we just did. And then I get to the last sentence or question. How many units should the company sell per month in order to break even? This last question or statement is going to tell you how to label your variables. How many units? That tells me I'm going to let X be the number of units. So, how many units should the company sell to break even? I'm going to let X be the number of units, and I go back and read the top of the problem. The Metropolitan Company don't care who it is, what it is, anything. But it sells its latest product at a unit price of $5. So it's $5 for each one. If we have X number of units, my revenue will be 5X. Alright, done with revenue. Moving on, next sentence. Variable costs, so the part that has the variable with it, are 30% of the total revenue. Okay. 30%, always use decimal form, so we'll call it 0.30. Right? 30%, 30 cents, same decimal form. 30% of the revenue, so of 5x. That's my variable cost. That's the part that has the variable in the cost function. Fixed costs amount to $7,000 per month. And this is asking me on a monthly basis, so I kind of ignore per month everywhere. Unit price. The X value is the number of units, and so the per month, this whole equation is set up, all of the functions are set up on the idea of we're looking at just a month. So the cost function is 30% times 5x plus 7,000. Guaranteed, every month it's going to cost $7,000. Now, how many units, find X, should the company sell per month in order to break even? Find X, break even. Break even occurs when cost equals revenue. So I take this cost function and I take 0.30 times 5x. 0.3 times 5 is 1.5 with the x plus 7,000. So here's my cost function, 1.5x plus 7,000 equals revenue, my 5x. Let's subtract 1.5x from both sides and I'll get 7,000 equals 3.5x. To get x by itself, I'm going to divide both sides by 3.5. 7,000 divided by 3.5 is 2,000, so I need to sell 2,000 units every month in order to break even. For each unit past 2,000, the Metropolitan Company is going to be making some money. If they don't sell 2,000 units in a month, now they're losing money. So that 2,000 is a really important number to know. More definitions. Like cost and revenue and break even, we also have demand and supply and equilibrium. A demand equation or demand function expresses demand Q for quantity as a function of the unit price P, price per item. A supply equation or supply function expresses supply Q for quantity as a function of the unit price P, price per item. Equilibrium occurs when supply equals demand. And frequently we'll say there is neither a shortage nor a surplus. A shortage would mean the demand is higher than the supply. And a surplus would mean nobody wants it, but you have a whole bunch sitting in stock. So neither a shortage nor a surplus is going to be saying, hey, that's equilibrium, let's let supply equal demand. Usually, if the price is increasing, demand goes down, right? The more expensive something is, the fewer people are willing to buy it. However, supply is going to increase as the price increases. Because if the price is $1,000 for the latest widget, the company's going to want to make some money. So they're going to produce as many as possible to meet whatever demand they have. But when that price goes down to only $800 per widget, now more people are going to want it. But the company's not making as much, so they're not going to want to supply it as much. Here we go. The demand for your handmade skateboards in weekly sales is Q equals negative 3P plus 700 if the selling price is P dollars. You are prepared to supply Q equals 2P minus 500 per week at the price of P dollars. At what price should you sell your skateboards so there is neither a shortage nor a surplus? Well, in either to have neither a shortage nor a surplus, we want to solve supply equals demand. To solve a supply equals demand, let's see what we can do here. Let's make this smaller, move it out of the way. And let's see about writing some stuff here. Let's use red. I'm going to add 3P to both sides. And when I do that, I'll have 5P on the left, my equal sign. But at the same time, I'm going to add 500 to both sides. Why do two steps when you could do it in one? And notice that we have the 3P's cancel here, the 500s cancel here, so I'll have 5P equals 1200. To get P by itself, I'm going to divide both sides by 5. Now, of course, 5 goes into 1,000 200 times, and 5 goes into 200 40 times. Put those two ideas together, and 1,200 divided by 5. I'm going to sell these skateboards for $240 each. That way, I don't have to have a big warehouse to store my extra supply, and I don't have customers that are upset that I don't have a skateboard ready for them when they're ready to buy. Supply equals demand, a nice little equilibrium when my handmade skateboards are $240 each. Example 6. First of all, I'd like to point out the year. This is 2004. If you can find a cell phone for $93 in today's society, you should buy it right away. It might just be a paperweight. It might only make phone calls. Heaven forbid it only makes phone calls. But it's there, and it's a great price. I think I just paid $1,000 for my last one. I almost choked when I realized that. So, back on task. Worldwide quarterly sales of a brand of cell phones were approximately Q equals negative P plus 156 million phones when the wholesale price was P dollars. Two questions here. If the cell phone company was prepared to supply Q equals 4P minus 334 million phones per quarter at the wholesale price of P dollars, what would have been the equilibrium price? And the actual wholesale price was $93 in the fourth quarter. We need to find out, was there a shortage or a surplus at that particular price? Let's take it one at a time. So, blah, 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 blah. The demand, or the sales, right? Sales, that's how many were demanded, was negative P plus 156 million phones. The supply was 4P minus 334 million phones. Equilibrium, I'm going to set the two equal to each other. So let's add P to both sides. 4P plus P is 5P. And here I decided to do two steps. So I have 5P minus 334 equals 156. To get the P by itself, I'm going to add 334 to both sides. 334 plus 156 is 490. To get P by itself now, 5P equals 490. I'm going to divide both sides by 5. The price is $98. So this says, if these cell phones were sold for $98, we would have had equilibrium. The supply would have kept up exactly with demand. But the actual wholesale price was $93, not $98. So if they sell for $93 instead, I could put the 93 in here for my demand equation, and 93 as a negative, and I add 156 to it. That's 63 million phones for the demand. But the supply, let me remind you that the supply function was a 4p minus 334 million phones. So if I put $93 in for P, and I take 4 times 93 and subtract 334, the company was only willing to supply 38 million phones. 63 million people wanted them because it was a cheaper price than Equilibrium. Only 38 million were being created. If I subtract the two, there's a shortage of 25 million phones for this particular company in this quarter of 2004. So if something sold out, that's because they're selling for less than Equilibrium, and supply does not keep up with demand. Watch for that. Christmas is coming up. Okay, I'm recording this in September, but still, Christmas is coming up, people. That's it. Thanks for listening.